Hello everyone, my name is Fazil Ahmad Khan and I will present this paper on a semantic framework for smart IoT farming. Starting with this paper, agriculture is highly sophisticated due to its highly dependence on natural environment, and there are a large amount of crops out there across the world. Among them is the cotton, which is the most important part of the crop for fiber production, and it has large application in textile industry. So the area of cotton farming is highly unpredictable due to its high dependency on the climate and the natural environmental conditions. So to address these challenges, due to the emergence of nano embedded sensors, wireless technologies, cloud computing, data analytics. So with the help of these latest technologies, the issues related to the environmental and climatal conditions can be addressed and can be minimized in the domain of smart farming. So the idea of integrating IoT in agriculture is to improve the traditional methodology or the practices into a new spectrum of smart agriculture to make the agriculture more sustainable and uh, more uh, more flexible uh, for all the different kinds of environments. So why there's a need to have any kind of agriculture? So there's a need to have a modern agriculture framework compatible with the high-tech sensors, the automation technology, the data analytics, the cloud infrastructure, the remote sensing support systems, and the decision support systems to minimize the issues faced by current day agricultural practices like the climate, the environment, the damage of the crops, the disasters. So these kind of the challenges addressed by today farmers. So with the help of latest technologies, this can be minimized to a great extent. So this idea gives the concept of precision agriculture in the agriculture studies. The way of integrating information and communication technology and the use of geosciences and remote sensing research and technology into a site-specific management. So the idea of SSM requires the observation and the measuring of a particular specific site for with the help of real-time data gathering technologies for different kind of operational purposes. So our proposed model supports a large-scale data processing with the help of real-time sensors for specifically for the cotton crops with the support of online platform to identify to use the platform use this model for different needs of the cotton crops. So it has the capability to analyze and predict the data for efficient decision making purposes for the farmers, for the fast reactive changes happening around the farms in the fields, the environmental problems, that the disaster or some any kind of certain event happening out there. So this model can detect this kind of events rapidly and notify the relevant farmers about the rapid changes in the environment. It also combines with the sensory data with the help of web services to forecast the climate changes and predict the feasibility of irrigation or fertilization of the crops into particular time period. So this is our model. On the top side, there are certain domains of application. In the middle, there is a cloud infrastructure. On the bottom side, there is a site-specific management applications. So components in our model, there are certain components in our model. Uh, Among them is a data wrapper. A data wrapper provides a collective path to describe the sensors into various domains using metadata information. The device manager provides a management of IoT devices automatically. Exploration module provides a scalable platform for the exploration and the plug and play feature for the enrollment and the discovery of the IoT devices. The data aggregation deals with a large volume of data and applying data compression technique into the raw data provided by data wrapper. Data federation module, the component, the purpose of this component is to respond the queries generated by the IoT devices. The event recognition is a tool to detect the event happening into the particular site. Real-time using is to generate the decision based on the data provided by the event recognition module to predict the happening to make the decision of what is happening in the particular specific site. The outward agent provides an interoperability with data heterogeneity, data handling, and support for protocols. Semantic data annotation is used to transform the data taken from the sensors into a meaningful form with the help of certain annotation models like SSN and OWLs. So by applying these models, the data flow from sensors can deployed inside the cotton fields can be easily understand and transform into meaningful form. In our case, with a specific reference to agricultural vocabularies and technologies for the efficient decision-making purposes for the farmers and the relevant stakeholders. Lastly, our model performs satisfactorily when analyzed when analyzed with the help of performance measures. We perform performance with the help of SQL query and C-Sparkle queries to detect the efficiency of this model of managing data rapidly, a large amount of data. So this model can work fine with the help of these two query languages, the SQL and the C-Sparkle. And on the other side, it has some limitations also, like the comprehensive adaptability to different environments based on the need of using the system. So that's all for this presentation. Thank you so much.